computer. But I'm Kevin Price. If any of you need to sign the form in the back for credit, I guess, as a crop consultant or whatever, the forms are back there in the back, and you're welcome to sign that. And let's see, I think, Don, where'd you go? There's Don. All right. Well, let's get started. I'm Dr. Kevin Price. I was a professor for 27 years, taught in the Department of Agronomy at Kansas State University. I was in the Kansas Biological Survey and the Associate Director of the Kansas Applied Remote Sensing Program for 19 years at the University of Kansas. And then I taught at Utah State University also. So I've kind of been around, and I took early retirement. And now I'm the Vice President of Research at AgPixel, which is our offices in Des Moines, Iowa. I'm going to tell you a little bit about what we do, try to make it not too appetizing. We want to stick to the technology and what it can do. Don Cummins, he is one of the dealers for AgPixel. He's out of Louisiana. Don, you want to raise your hand? He's going to be talking in a minute. I'm going to go over the basics of the technology fairly quickly, and Don's going to focus on the applications that relate to rice and cotton. And we're obviously glad to answer any other questions you've got. How many of you, let me just ask this, how many of you have ever flown a drone? No, not very many. All right. All right, of those who've flown a drone, how many of you have ever crashed your drone? And of those who've crashed their drone, how many of you picked it up in a black garbage bag? All right, so I just want to start that off. You need to understand there is a certain amount of risk. There's a lot of excitement about what the technology can do. A number I throw out, I don't have any numbers to validate this, is that the average life expectancy of a drone is maybe 1 year. I've heard more like 15 seconds in some cases. But anyway, I want you to know. Now, how many of you have heard of NDVI or understand what NDVI is? All right, okay, that leaves enough of you that I'm going to talk about that a little bit. Because what the drone is really the platform. It's not the imaging system. And the imagery is, again, just pictures, unless we can take those pictures and turn them into useful information that a farmer or an agronomist or someone can make a good management decision using that technology. So it's not of any value until we've turned it into information that can be used to make a good management decision. So that in terms of this technology, when we fly the imagery, we capture usually multispectral imagery, meaning multiple wavelengths. Usually we want a visible, a near-infrared wavelength at least, because we're going to use that to compute an index I'm going to tell you about in a minute called that normalized difference vegetation index. But plants, the reason we want a visible band is because plants are using visible light for photosynthesis, and so they absorb energy in the blue and the red wavelengths, and the plants want to get rid of near-infrared energy, and so when a photon comes in the near-infrared wavelength and hits a plant leaf, it's like a pinball in a pinball machine. It's bouncing around inside the parenchyma cells, the palisade cells of the plant. It's bouncing around, and by random chance, half the photons go out the bottom of the leaf and half of them go out the top. And so if you've got another leaf layer underneath, the same thing happens, so it becomes a magnifying effect. So what you have is that in the visible light, the plant is absorbing the energy, so the wavelengths are not much of it's getting back into the camera. And in the near-infrared wave region, many of it is being reflected back into the camera and magnified by increased leaf area index or increased biomass will increase the amount of near-infrared light. So I'm going to show you what we'll do with that in just a second here. Now, the point here is that the indices, gentlemen, there's some chairs right up here. You're welcome to sit. If you want to stand, you can stand all you want, but just let me know. Okay. What we're really measuring with these vegetation indices is chlorophyll density. So the more chlorophyll you've got, the higher this index called the normalized difference vegetation index is going to be. And the cameras we're flying on the drones or the Cessnas, the satellites that are using really expensive scanners, they're sensing the amount of chlorophyll if you're working with the wavelengths that are in that region of the spectrum that chlorophyll affects. So when you do remote sensing, you're remote sensing right now. you're looking at me, you're looking at the picture, and you're sensing it without being in physical contact with it. And that's remote sensing. The difference is that the sensors that we use record the amount of light in digital values that we can then analyze in a computer as opposed to in our mind. Now, we often have to do a lot of that mind analyzing as well. But so let me just give you an example. When I was at Kansas State University, I went into the greenhouse and took a picture in natural color and near infrared of this soybean plant that's sick. You can see where it's stressed. It's going into chlorosis. Chlorosis, any plant that's stressed turns yellow. And the reason it's turning yellow is because when it's stressed, just like us when we're stressed, we produce free radicals. And the free radicals destroy or break down the cell structure of the plant. In order to fight that, the plant produces antioxidants, and carotenoid pigment is an antioxidant. So it's fighting the stress using an antioxidant called carotenoids. And carotenoid pigments are the yellows and the reds and so on. So if the plant is doing this, it's fighting the free radicals that are being released by the stress, either not enough nutrients, not enough water, too much heat, too cold, whatever it is, okay? So the instruments that we use are very sensitive to the pigmentation change that takes place in the plant. And so as it turns yellow, the instrument picks up those differences and tells us something about the plant. So what do? Well, this is 4 different wavelengths. This is the blue. That's the way that plant looks if I gave you all a pair of sunglasses that only let blue light in. This is the way the plant would look. It'd be dark because it's absorbing the blue light is being absorbed by the plant. If I gave you a pair of green sunglasses, this is the way it would look. And plants are actually very dark. The green pigmentation of the plant is dark because it is not reflecting much light. But the part that's sick is reflecting more green light than the part that's healthy. I didn't point that out, did I? This is the healthier part right over here. That's supposed to say healthy. I don't know what happened to that. But anyway, and this is red. And the plants are absorbing a lot of energy in about the 680 nanometer region, which is in the middle of the red region of the spectrum. So the plant part that's healthy is darker because it's absorbing that red light, just like it is the blue. And finally, the near infrared. Now notice that in the near infrared, I can't tell the difference between the sick dead leaves on the floor or on the table and a lot of the different leaves that are on the plant. Near infrared alone is not going to allow you to distinguish between stress in a plant. It is a combination of the visible and the near infrared that make that possible. So what we do is this is the simplest index. We take the near infrared energy in this image and we subtract from it the visible light, often the red, but can be the green or the blue wavelength. We subtract the visible light from the near infrared to get the difference. If the plant is healthy, it will, or if it's got multiple canopy layers, it'll be high in the near infrared, it'll be low in the red. So the more plant material you've got, the higher the number is going to be. Then we normalize it by taking the near infrared plus the red or the visible light and dividing that into it, and that's why they call it the normalized difference vegetation index. And the more plant material you've got that's healthy and photosynthetically active, the higher that index will be, the NDVI. And now this is the black and white showing you the healthy part of the plant now is showing up as bright, the sicker parts of the plant are darker, and the dead leaves on the table are very dark. And that's the way that index works. When we fly this on a drone or a Cessna, in a drone at 400 feet, we're mapping literally every square inch of the field and giving you an index value like this on the field. So that's basically what it boils down to. When we fly a Cessna plane at 3,000 feet, we're getting about 3 or 4 inch pixel sizes. So we're doing the same thing at a little coarser resolution. All right, so this is what it looks like if we colorized it and made sure that the high NDVI values are green and the lower ones are reds or oranges, and the table that has no chlorophyll is purple. And this is what we call a false color composite. In the interest of time, I won't talk about that except to say that when you see a color infrared image, the redder it is, the greener it is, all right? Just remember that, red means greener, red means green, and you'll be all right. All right, we're going to talk a little bit about the drones, and then we're going to talk about applications. Since not very many of you have flown a drone, there are basically 2 types. There's what we call a fixed wing, and then there's a multi-rotor. And most of you starting out should, if you're going to fly one, should fly a multi-rotor. Probably not this one. This is a little more sophisticated. Probably the white ones you see, the Phantoms or something like that, would be a good starting one to start with. Then if you break it, you're only out $1,500, all right? This one here, you break it, you're out about $3,000, so it's about twice as much. Plus your camera, and the cameras can be pretty expensive too. But this one is easy to fly. We can have you, if we were training you to fly, you could probably be flying this, at least controlling it, in a few minutes. To really understand how it works is going to take more time than that, but to just be able to fly it and move it around and bring it down and land it. I've literally been standing next to a graduate student while I was flying at Kansas State, and he's going, wow, that's cool, and I handed him the remote and said, fly it. He's flying around, really nervous. I said, land it. And he land it? He said, So I had him bring it down and land it. He'd never flown one, and he was able to land it. This one right here, you're going to be sweating blood. Because this one's designed to fly by wire, so it's somewhat easier to fly. And Don's flown it. He's built one of these. This is one that we build for our dealers. It's mostly to try to keep them from having to pay an arm and a leg for a drone because they're expensive. So we try to keep the price down on this for the dealers. That one can carry 6 pounds, can fly. We've had dealers that fly them for about an hour on one battery charge, but it's a big battery. And we can fly, in a day you can fly about I'm just throwing out numbers. Some of you say, well, I can fly more than that, and I can fly less than that. An estimate about a ballpark is about 1,000 acres a day with one of these. And if you're flying mappable imagery, if you're just getting up and looking around, you can do lots of acres. But if you're flying and actually mapping with the system where you're getting lots of overlap and all that, I've said usually about 50 acres a day. Some people say, well, I can get 100 acres. So anywhere, somewhere around 100 to 50 acres a day with this type of instrument. It's kind of a slow flyer and so on. And this one here, maybe 1,000, around 1,000. Now that, if you're trying to make a livelihood doing that, it's going to be hard to make a livelihood with that many acres. So I just want to let you know that we figured out real quickly, we had some of the best drone pilots in the world. You don't get to escort the Predator back into the United States if you don't know what you're doing with drones. And our pilots, they're all certified to fly jet aircraft, twin engine jets, and can train in that area. So they didn't just fall off the back of the hay wagon, as we said, where I grew up in the real small town. But even then, one of our drone pilots said he's up to $1 million in crash drones right now. That's his tally. So in a way, that's kind of a rite of passage. If you think that they're not going to crash, you haven't flown one. All right. All right. So here's the advantage of this too: is you can put a camera on it with a gimbal and keep it pointed more straight down. That's one of the advantages of flying it. And here's a video showing us doing some high throughput phenotyping work at Kansas State University. A couple of my grad students getting ready to fly. The different colors is so you know which way you're oriented. If it gets turned on you and you don't see it, you'll fly it away from you instead of towards yourself. We're flying winter wheat here. We use this to get estimates of yield and biomass. The person who planted this field cringes every time we show this one because he said the planter GPS was not working right. His graduate students did it right. And this one's flying, I think it was an S100 camera, Canon camera, about 12 megapixels. Since then, we fly a higher end camera to get higher quality imagery. This is the color infrared. Remember, the redder it is, the greener it is. We flew so low on some of the missions, we literally could count the green heads on the winter wheat. But you can see the level of detail we're getting with this particular overflight. Get my good side, please. All right. So this is our RF-70 flying. Our company name was Robo, but we changed it to AgPixel because we were more into the image processing than just the drone imagery. But This one it has 4 bays on it, so you can load a thermal scanner, a regular camera. If you want to, you can carry over 6 pounds on it. So it was built for carrying multiple scanning devices. You can see the bays that are in it. And it's big enough that you don't just go out and throw it in the air. You have to launch it with a bungee launcher. But other aircraft were using a $2,500 catapult. Ours was a $30 bungee cord, okay? You'll see Daniel walking out in the field in a minute. Here's Daniel going to pick it up. He's one of our drone pilots. And you're going to see, if you look closer, you'll see it's hooked to a bungee cord. And the bungee falls off after he launches it. It has balsa wood elevons that makes it so that it's very responsive. So you can see he's intentionally jerking it around. The fins, if they break, it's not like I'm trying to sell you one, I'm not. I'm just trying to tell you things you want to look for maybe in aircraft. The fins, you can go to Hobby Lobby and buy them if you break them. So they're just foam core like fins. He's flown this in 50-mile-an-hour winds, not very fast, but he has flown at 50-mile-an-hour winds. Going one way, he said he's doing about 100 miles an hour. Coming back the other direction, he's doing about 5 miles an hour. So it's a bigger, heavier plane. But because of that, we can fly a higher quality camera on it. We're going to land it. I think it's some wheat stubble. And it looks like the prop breaks, but it's a piece of wheat stubble falling up. Just before it lands, the prop parts right behind it horizontally. All right. Now, what I want to tell you too is that this particular, most of our work now is with Cessna, because we found out that our dealers and we could not fly enough acres with a drone and make a living, all right? If you're just doing it for a hobby, if you've got small fields, then a drone is great. If you're trying to fly 1,500 acres or 3,000 or 4,000 acres, pretty soon the fun factor wears off. And that's a lot of what drives the industry, is the fun factor. People are really, we're all pretty enamored with these things. They're pretty interesting. But once the fun factor wears off, you're saying, how can I fly? I've got a person who wants me to fly 10,000 acres for him. I can't do that. Mostly I'm trying to fly all summer long, trying to go get the right weather conditions, get everything done just right. So what can you do with the Cessna? Give you an idea. We had a company in California said, all right, you said you can do great work with the Cessna. Count these tomatoes in our field. Tell me how many tomato plants are in that field. So we were able to go in and pull up the NDVI values. We built a little algorithm that counted them, and we said, you've got 800. Well, I remember saying to them, well, how many tomato plants have you got in the field? And their answer was, you tell me. And so we said, well, we counted 806,856 tomato plants. So I said, am I right? Are we right? And they looked at each other and they said, well, I said, so how many tomato plants are there in the field? They said, we don't know. We don't know. Why not? Because we've never counted them. Who wants to go out there and count that many tomato plants, you know? But they said, you're really close. And I said, well, how do you know? I said, because we try to plant 8,000 tomato plants per acre, and this is a 100-acre field, so there should be around 800,000 plants. So anyway, that's just to show you that you can get pretty darn good data with the Cessna. And I'm going to turn the time over to Don now and let him talk about stuff that most of you are more interested in. That's rice and